So in terms of where our SSDs are used, they're pretty much used everywhere. Kingston started shipping SSDs in 2009, and our first generation was actually co-branded with Intel, if you guys remember the M series and the E series. And then we started building our own SSDs, and we've been building them since then. So our SSDs are pretty much used across all kinds of applications, and they're used everywhere. We have currently 2.5-inch form factors, M.2, M-SATA, and half-height, half-length PCIe form factors. And the use cases are very divergent. You can have the client systems where people are using them in desktop, notebooks, workstations, and in addition, servers. We have all kinds of use cases, for example, from personal computing, as I mentioned, to commercial, video surveillance systems. We have one customer using our SSDs to capture data from radar on an airplane and then analyze the data to optimize the radar system. We have digital signage, for example, as usage case. So usage cases are all over. Cameron and I are always learning about new usage cases. So pretty much anywhere where you have a hard drive is where you're finding our SSDs. So they're pretty much all over. The OEM world is pretty much your major OEMs, but they also include a lot of tablet and other system manufacturers that you have in the Far East. But the fastest growing market is the data center market, and that's what we'll talk more about in terms of our focus and our product line. So you guys have been hearing a lot about NVMe, right? NVMe is the hottest new thing, and it'll be a major technology transition. So the PCIe bus has been around for quite a few years, and the PCIe bus is a fast bus. It's not only scaling in terms of frequency with every generation, you're getting more bandwidth. Currently with Gen 3, you have 1,000 megabytes per lane, but you can also scale it by the number of lanes, so you have multiple ways of scaling it up. It's a very scalable bus. So when the SATA I/O organization looked at SATA 6 gigabit per second, for example, they looked at it and they went, you know, there's no way for us to keep increasing the speed. For SATA, for client systems, it's fast enough. But you already have a bus that exists. It's the PCIe bus. How do you make that usable for storage? Just like you're using it for networking cards, for graphic cards, it's a bus that has a root complex in the processor. So they came up with NVMe, and NVMe is a driver. So pretty much it's the software side. Even though people use the term NVMe for the hardware side, it's actually the driver. It's what makes the operating system understand flash. So NVMe is actually a replacement for AHCI, which was a hard drive driver. So on a lot of client systems, for example, your system may be talking to the SSD as a hard drive. And there's a lot of overhead. SATA has over 120 commands. And when they looked at NVMe, they said, you know, we don't need all these commands because the SSD is ignoring a lot of them. So NVMe has actually got about 13 essential commands, and that's all you need. And by doing that, you reduce overhead. So NVMe gives you great performance, lower power consumption at the SSD level, but the best benefit is at the processor level, it's saving you processor cycles that you would be using on SATA drives. So you also get back processor headroom. So NVMe has a lot to offer, and the whole industry is moving to NVMe. And within the next 3 years, industry analysts are saying you will see NVMe dominate. You will see SATA shipments go down. Even though SATA will still be available on legacy systems, there will still be upgrades. New systems will go NVMe on all platforms. Client systems already have NVMe slots, and you'll start seeing these more and more on servers, and we'll talk about those form factors. So if you look at the history of NVMe, people who started thinking about the PCI bus for storage were actually very innovative at the time. You guys remember which company that was, right? That made a name for itself for SSDs that lived on the PCI bus. Starts with an F. Fusion IO. You guys remember? They would sell low-capacity SSDs at the time, and they were very expensive, but they were super fast. And they pretty much dominated a lot of companies at the time, like Facebook and others, and they were using these NVMe cards. They were very expensive. They were proprietary in terms of drivers. You had to use their drivers because the operating systems did not know what these cards were. So you had to use their drivers. They're difficult to scale. You rarely were able to have multiple ones in one box. They were expensive. And the key problem with them was the single point of failure. What happens if the card fails? You have to power down the server. You've got to replace the card. And that's always an issue at the server level. Customers like the ability to be able to hot swap. And we'll talk about what's happening to that. So the industry started looking at this, and they said, this is a great idea. The PCI bus is a fast bus. It's already there. Why don't we use it? Well, to make it usable, they had to standardize the interface. They had to make operating systems understand SSDs and flash. And that's where the industry developed NVMe. So a few years ago, they started putting in NVMe drivers in all the newer operating systems. So today, it's pretty much there. If you buy a newer version of Windows Client, Windows Server, Linux, NVMe is already put in there. So if you plug in an NVMe device, it's automatically recognized, and you get the benefit of performance. So the technology is right now in the process of ramping up. And on the client systems, you already have NVMe on a lot of your notebooks. For example, on the Lenovo X1 Carbon, you already have NVMe SSDs internally. And you're going to really see a ramp up on the server side. And Cameron will tell you more about what you'll see on the server side. So the mainstream solutions that are coming up that will dominate in the next 3 years will be affordable. You're not going to have to pay an arm and a leg. They're going to be relatively inexpensive, but they'll give you great performance. NVMe drivers are in-box in the operating systems. You don't need drivers from Kingston or other vendors. You plug it in, it works right away. They'll come in 3 different form factors for flexibility. Half height, half length, also like an add-in card that you would plug into the PCI Express socket. U.2, which is the 2.5-inch form factor that you'll be hearing a lot more about. And of course, M.2, which has replaced SATA and is a small form factor that can fit in notebooks, desktop motherboards, gaming boards, and also some servers as boot drives. So and these will be very scalable because now you have the PCIe bus, you can scale it up as long as you have lanes available. So these are the 3 different form factors of NVMe SSDs. First one, which is the oldest one that has been around, is the half-height, half-length add-in card. Mostly for server data center applications, you can get great performance. You can assign more lanes to this card. You can have, for example, 8 lanes, and in the future, 16 lanes. That'll give you great performance. With Gen 3, for example, each lane is 1,000 megabytes per second. So 4 lanes theoretically can give you 4,000 megabytes per second. So you can get a lot of performance. And then high-end workstations, graphic workstations. At our booth, we're showing an NVIDIA workstation where we're rendering red 8K raw video, real time, using one of these cards, our DCP-1000, to accelerate the GPU and give it great performance. And you can see it render graph the video with 0 drop frames, which is amazing. So please stop by our booth. And then you have U.2. U.2 or Universal.2 is the 2.5-inch form factor that you'll start seeing on servers. It is basically a x4 interface on a connector. And the connector is a universal connector, which means that server manufacturers can actually design the connector on the motherboard to accept SATA, SAS, or NVMe. So actually, depending on how the server is configured, you may have 4 slots, and you can have up to 24 slots of U.2. And tremendous performance. Think about having 4 lanes of PCIe and over 3,000 megabytes per second. And this can be used in all the new form factors that you're seeing in new servers that you'll see on the show floor. And then M.2, which is already available, that's our KC-1000. It's mainly for client applications. It can also be used as boot drives on servers. And that's a 4-lane M.2. And we'll give you more details on that. But one of those little gumstick-sized SSDs can give you up to 2,700 megabytes per second read speeds. I mean, you've got to think about that. SATA is 550. So you're getting a huge increase in performance. And it's going to really empower faster systems overall. Gone will be the days where you have to wait a long time for your system to boot up. So these will be used in all kinds of client applications, notebook, desktop, workstations, as well as specialized or purpose-built systems. So this is our KC-1000 that we already are shipping. It's available in 2 form factors. One is the M.2 by itself. And that's good if you have a motherboard that has an M.2 and NVMe socket. You can plug it right in. A lot of gaming boards from Asus, ASRock, and Gigabyte have these. Or we have them coming with an adapter card. So if you have an older system, you put this on, you plug it in, your newer operating system picks it up, and automatically you get great performance. It's using a Phison E7 8-channel controller. It's PCIe Gen 3 by 8. So theoretically up to a maximum of 4,000 megabytes per second. 290,000 IOPS. So you're getting very fast performance. If you look at 2.5-inch SATA, you're nowhere near the kind of IOPS you get from one of these NVMe drives. No drivers needed, which is great. plug and play, right? That's the ideal storage form factor. We offer a 5-year conditional warranty. And we also have a Kingston SSD manager that allows you to see the status of the flash drive, see how much wear you've put on it, and you can track a lot of smart attributes as well. So it's ideal for all kinds of applications where you want high performance. But this will migrate down to your notebooks as well, where you're going to get used to having NVMe drives with very good performance.